Welcome back to a new machine learning tutorial. In this video, we are going to talk about k-means clustering. We are going to talk about the logic behind the algorithm. We are going to code it in Python. And we are going to talk about how we can find the optimal k value using elbow method. Let's start coding. I'm in the Visual Studio Code page. I'm going to be using this code editor, but you can prefer any code editor that you want. I'm going to create something like k-means clustering, and I'm going to create a Jupyter notebook like this. Next, I'm going to select my kernel up in here, and then I will say k-means clustering. So let's talk about it. This is an unsupervised machine learning algorithm used for clustering data into distinct groups. The algorithm assigns data points to clusters based on their distance to a cluster center called the centroid. So we can type something like distance to the centroid. So the aim is to minimize the sum of square distances between the data points and their assigned cluster centroid. So step by step in the initialization, we randomly select k points as initial cluster centroids, and in the assignment side, for each data point, we calculate the distance, generally Euclidean, to each centroid and assign it to the closest centroid cluster. And then we recalculate the centroid by finding the mean of all points in the cluster. I'm going to name it as update. And then at the end, we are going to step as repeat, where steps 2 and 3 are repeated until the centroids no longer change significantly or a predefined number of iterations is reached. And the goal of the k-means is to minimize within cluster sum of squares, and we can type its formula like x minus u and squared. So let's talk about these components. By the way, we are going to do this operation for every c. I'm going to write it like this, and in here c is the set of points in cluster I, and x is the data point, and this is the centroid of cluster I. So you can think it like, I'm not trying to make it complex, so I'm not typing the i's, but we are going to do this for all of them, and we are going to determine data points minus centroids. Okay, so this is our mathematical formula, and now we can start coding. I'm going to start by importing some libraries for data creation and visualization part. I will say from Scikit-Learn, datasets, import make blobs. We are going to create our data with this. I will say import matplotlib.pyplot as plt, and I'm going to say import numpy as np. So next up, we are going to create our data. I will say x, y, make blobs. I will use number of samples 300, and I'm going to set centers as 4. Next, I'm going to say cluster, standard deviation 1, and I think it's going to be a good one. So I'm going to make the x run, and I'm going to make the y run in here. So we have a vector like this, and we can check their shape like x.shape and y.shape. So it's 300 to 2 and 300, matrix and a vector, and let's quickly visualize it like plt scatter. I will say x and I will say 0 like this. Next up, I'm going to index it and take the first column. I'm going to say s equals to 50, and I'm going to use plt.show, and we are going to have a data set like this. So we are going to group it, these data points, and if you want to change this data, you can simply make this rerun, and when you plot it again, you are going to see a different one. Let's get an exact different one like this. Okay, we have 4 different groups in here. Now we are going to implement k-means algorithm using Scikit-Learn. So I will say from Scikit-Learn .cluster import k-means. Next up, I'm going to initialize it like k-means, and I will say k-means. Now I'm going to set the number of clusters 4, but I'm going to show you how you can decide on this number of clusters, because in real world datasets, you are not going to have a dataset like this, and you are going to have a much complex dataset with more groups, or maybe less, but it's going to be more complex. So we have a method for finding the optimal number of clusters. So we initialize the k-means with 4 clusters. Next up, I'm going to fit the model like this, and actually let's see what we get. Future warning. Actually, I don't want to see any kind of warnings, so quickly I will say import warnings, and I'm going to say warnings.filter warnings. I will say ignore. So in this way we are not going to get unnecessary errors or warnings. Okay, so we are still going to see if we have errors, like I will call k-means that, let's say, instead of fit, I will say phi, and we are going to get an error. But right now, since we did this filtering operation, we are not going to see any kind of depreciation or future warnings. They are useful when you're developing things, but it's just a tutorial, so it's not important. So next up, we are going to say k-means.predict, and we will pass x. So it's going to be predicting the cluster labels. And I'm going to set this like y k-means. It's going to be like that. And now I'm going to plot the cluster data with centroids. So I will say plt.scatter. I will say x, again 0 firstly at the first place. Next up I will say 1 instead of 0, like this. And I'm going to set my c as y k-means. I'm going to set the s as 50, and let's set the cover map as vertices, like this. So we are going to have a data. Actually, we can call plt.show if we don't want to see this. And we can see that we have a data like this. It's looking beautiful. So we were talking about centroids. How we can call them is we can say k-means means on the fitted thing, like in here it's k-means here where we initialized it and fitted it. So k-means, and we can call centers like this. And now we have this cluster centers. It's actually the coordinates, and we can save them to something like centroids, and it's going to be equal to the k-means.cluster centers. Next up, I'm going to copy this quickly. I'm going to copy this plot creation, and now I'm going to add centroids to this plot. So I will say plt scatter. I'm going to call centroids, and I will take like 0 firstly. Next up I'm going to take 1. We are passing the coordinates we have, and I'm going to set the color as red. And what else we can pass in here is we can say s equals to 200. We can say alpha equals to 0.75. Actually, let's say 1. I'm going to set the marker as x. So next up I'm going to say something like plt.title k-means clustering results with centroids. So I'm going to make this run, and we are going to have a beautiful. Also we can make them bigger, like let's say 2000 for the axis, just for seeing them clearly. And now we can see the centroids clearly. Great. Again, we initialize the k-means model with 4 clusters, since we know we generated 4 blobs. But what if we generated with 3? Then I'm going to say 3, like in here. Centers is going to be 3, but I'm going to keep k-means as 4, and I'm going to make them run all again. So this time we have a different plot like this, and you can see our centroids. We have 3 blobs, but we are trying to have 4 centroids since we initialize it with k-means, number of clusters 4, and it seems different right now. Let's do another example with changing our data. I'm going to set centers is going to be 2, and I'm going to say number of clusters is going to be 3 right now. So I'm going to make them run all again, and we see that we have a different looking plot right now with 2 blobs and 3 number of clusters. What if we say 6 centers? Actually, let's say 5, and I'm going to make them run all again. And we will see right now we have different grouping operation, but in here, in my opinion, 4 number of clusters is going to perform much better, since we have 1, 2, 3 and 4 groups in here. So how we can find that is I'm going to just quickly change this to 4, and I'm going to quickly change this to 4, and I'm going to make them run again, and I'm going to show you how we can find the optimal number. Actually, I'm going to create a different data set. I'm going to get a better looking one, Actually, this is much better, but maybe we can improve that. I'm looking for something just like this one. Okay, great. This seems amazing. We talked about the within cluster sum of squares in here. So how we can get that value in here is we can just call k-means.inertia. And here is our value. So a lower value is generally better, but it doesn't always indicate the best number of clusters. So for finding the optimal number of clusters, I'm going to show you the elbow method. The elbow method helps determine the right number of clusters by plotting these inertia values for different values of k, which we can also say number of clusters, the thing we initialized in here. The point where inertia starts to flatten is considered the optimal k. So we can say WCSS and it's going to be an empty list, and let's say that actually we are working on this data. I want you to remember, so we can set this apart. Now our optimal number is 4. So in our elbow method for finding the best number of k, we need to get the result of 4 in here. So I'm going to do that right now. I will say this. Next up I will say for k in range, let's try them from 1 to 15. I will say k-means is going to be equal to the k-means, and actually like this. Number of clusters is going to be equal to the k. Next up, I'm going to say k-means.fit for every k value in range 1 and 15 that we are passing in here. And I will say our list append k-means.inertia. And actually, there's a problem. Oh, I forgot to pass x in the fit. So it's going to be working in here, and we have a list like this. So let's plot it and see what's the optimal value of k. I'm going to say plt.plot range 1 to 15, the value in here, and I will say my list, and I'm going to set the marker as this. Next up, I'm going to give the title like elbow method, and I'm going to give an x label like number of clusters. I'm going to say plt.show. Actually we can add a y label too, like y label this, and actually we need to close the parentheses, not in here but in here. So we are going to have a beautiful plot in this. So in here we see that 4 is the optimal number, also 2 is a great number. Let's check our data again. I'm going to delete this one, and yeah, actually 2 can be applied, 1 in here, 1 in here. So let's create a different data set by running all of them again. And now we have 4 different separate groups, and we are going to see that 4 is going to be the optimal here. So again, I'm going to type it since it's so important. The point where our loss starts to flatten is considered the optimal k. So it's 4 in here. And this is how we can determine the optimal k value in your dataset. And that was it for this tutorial. Let's summarize what we did in this video, and then we can finish this tutorial. So we started by talking about the k-means clustering, the steps we apply, and in here we talked about the criteria for finding the best k value. Then we create the dataset with 4 centers. Next up we plotted it, and we initialized a base model like this. We set the number of clusters as 4 since we know we created our data with 4 blobs. Next up we fitted it, trained it on our data, and we visualized it. We visualized the centroids in here. I showed you how we can reach the centroids, and here we have the k-means clustering results with centroids, and I talked about how we can get the within cluster sum of squares. And in here we talked about the elbow method for finding the optimal k value, and we decided it's 4 in here. And I wrote a definition like the point where within cluster sum of squares starts to flatten is considered the optimal k. So that was it for the coding part. Let's get to the outro. Thanks for watching this tutorial on K-means clustering. I'm sharing new data science videos every week on my channel. You can subscribe to my channel for more videos like this. Also, I have a playlist named Machine Learning Tutorials where I have more than 40 tutorials just like this one. You can reach to that playlist from the cards of this video or from the description. Have a great day.